Algebra 1, Lesson 63, we are looking at our systems of linear equations one more time and looking at how we can solve them with elimination. We've done it with graphing and with substitution, but now we're going to look at elimination. What we can do is, since these equations are on the same coordinate plane, we're looking for the same x and y, we can actually add the equations together by looking at those like terms. When we do this, we have them in standard form, which means that our x and the y are on the same side of the equal sign. We're looking for opposites when we add. We're looking for, in this case, we have a 5 and a negative 5. Maybe in another one we could have a 6y and we would have to change this equation to maybe get a negative 6y. We're looking for those opposites in order to add our equations so that one of our variables gets eliminated. In this case, the x gets eliminated because 5x minus 5x is just 0. So we add everything else up and we say 2y plus 6y is 8y, 9 plus 7 is 16, and now we get to solve for y and say it's 2. Now all we have to do is substitute 2 and for y in one of the equations and solve for x. In this case, we end up saying, well, let's do it. Let's plug it into the first equation, and we get 5x plus 2 times 2 is equal to 9. Well, that's 4, so I'm going to subtract 4 on each side, and we see that 5x is equal to 1. Or, sorry, 5x is equal to 5, so x is equal to 1. Well, we can check our solution, 1, 2, in the other equation by doing negative 5 times 1 plus 6 times 2. Does that equal 7? Well, yeah, negative 5 plus 12 does give me 7. So this is the solution. Now remember, a solution to a system of equations must be written in the form of a coordinate pair because it's the intersection of these two lines. We need to make sure it's as a coordinate pair. Let's try another one. So when we add these up, we see, okay, 3x plus 6x, we get 9x. 7y minus 7y, it eliminates the y, and 16 plus 11, 27. We can divide by 9 and get x is equal to 3. Now we can plug that 3 back in to x in either of the equations. Let's do 3 times 3 plus 7y is equal to 16. So I can subtract 9 on each side, and I get 7y is equal to 7. So y is equal to 1. The coordinate pair for this solution is 3, 1. And if we plug it into the second equation, to check it, we will get 6 times 3 is 18, minus 7 times 1 is 7, and that does give me 11. So my solution is correct. Next one. 7x plus 3y is equal to negative 5, and 2x plus 3y is equal to 5. Well, when we look at this, if we were to add these up, we would get 9x plus 6y equals 0. That wouldn't get rid of any of my variables, so we need to have another plan. And one way to go about this is subtraction. We can subtract the second equation. But we need to be very careful because each of the different parts of the second equation need to be subtracted. So I'm going to be doing 7x minus 2x, that gives me 5x. 3y minus 3y, well, that eliminates the y's. And then negative 5 minus 5 gives me a negative 10. So I can divide by 5 and get x is equal to negative 2. And I can plug this back in to get 7 times negative 2 plus 3y is equal to negative 5. So we have a negative 14 we're going to add to each side. And we get 3y is equal to 9, so y is equal to 3. So our solution would be negative 2, 3. Now, if this method doesn't work for you, let me show you another method of going about this. Subtraction will work, but oftentimes it's pretty complicated when we add in a bunch of other negatives. So for example, this one. We could subtract these two equations, so we would subtract the second equation, and we would say negative 2x minus a negative 2x. Well, okay, minusing a negative is adding, so I have negative 2x plus 2x. It gets kind of confusing. Well, we've eliminated the variable, but it's hard to sometimes see the rest of it because we have to subtract everything. Well, another way that you could go about this is continue adding. If you like the idea of adding these together and finding those opposites, what I need to do is change one of the equations in order to get an opposite. So I see these two x's. Really, I need one of them to be a negative 2x and one of them to be a positive 2x. So maybe I decide to change my first equation and multiply it by negative 1 on each side. We got to do it on each side. And when we do that, we get an equation of 2x minus 2y is equal to a negative 18. So that when we add these together, I just have to add. I get 2x plus a negative 2x, well, that's a 0x. Negative 2y plus a negative 7y gives me a negative 9y. And a negative 18 plus 9 gives me a negative 9. So that when I solve for y, I find that y is equal to 1. And I can plug it back in, let's say, into the second equation. So we have negative 2x minus 7 times 1 equals 9. Well, that means I'm going to have to add 7 to each side and get negative 2x is equal to 16. So x is equal to negative 8. So my solution is negative 8 comma 1. So if the subtraction method gets a bit too complicated, try adding again. You'll have to change one of the equations in order to find those opposites. In this case, I found an opposite by doing 2x and negative 2x, because when I add those, they will eliminate my x variable. How about this one? So we're going to need to change both of the, or change at least one of them so that they're both in standard form. When I do that, I will get negative 8x plus 5y is equal to negative 2, and 4x minus 3y is equal to negative 2. Now, when I look at this, I see that even if I added or subtracted them, I wouldn't eliminate a variable, which means I'm going to need to find a multiple of one or both of these equations so that I can add them together or subtract and eliminate one of the variables. So I look at the coefficients of each of my like terms. I look at negative 8 and 4. I look at 5 and negative 3. Well, it seems to me like the negative 8 and 4 have more in common. They have a closer multiple. So maybe I can get a opposite by multiplying this second equation all by 2, so that I will get a positive 8x, which will balance out the negative 8x. I'll get a minus 6y is equal to negative 4, so that when I add them up, the negative 8x and the 8x eliminate my variable. And I get negative y is equal to negative 6, so y is equal to a positive 6. We can substitute it back in just like normal and find my coordinate pair. So sometimes it's necessary to use a multiple of the equation in order to actually get rid of one of the variables. So just like that one, we're going to do the same type of thing for this one. 4x minus 3y is equal to 15, and 6x plus 5y is equal to negative 25. When I look at these, I have a lot of options. I could find a common multiple of 15 for the negative 3 and the 5, or I could find a common multiple of 12 with the 4 and 6. Either one of those options is going to make me multiply both of the equations by a number. Okay, so maybe we use the 4x and the 6x. Well, if I multiply the top equation by 3, I'm going to get 12x minus 9y equals 45. And then I would have to multiply the bottom equation by negative 2. This will give me opposites so that I have a 12x and a negative 12x. So that when I add them up, I get rid of the x's, and I have a negative 19y is equal to 95, which means that y is equal to 5. Well, then we can plug it back into one of our original equations and find our x value. So sometimes it's necessary to do these multiples and just look at the ones that they have in common. Maybe they have a least common multiple that's really close. And so you just have to multiply by some smaller numbers in order to get something to even out. Okay, so in this case, if I look at 2x and negative 5x, 2y and negative 3y, maybe I multiply to get rid of the y's. They have a common multiple of 6, so all I would have to do is multiply the top equation by 3 and the bottom equation by 2. Since one is positive and one is negative already, I will end up with opposites. I will get 6x plus 6y is equal to negative 24, and I will get negative 10x minus 6y is equal to 28. So that when they add up, these go away and I get a negative 4x is equal to 4, so x is equal to negative 1. And I can plug that back in to solve for y. Okay, so these are just a couple, I won't go through the entire thing with this, but we'll just set it up. This is a word problem that you often see with these system of equations. So Senora Hilbert has 32 buffalo nickels. Some have dates and others don't. The nickels without dates are worth 15 cents each, and the ones with dates are worth 75 cents each. Altogether, the nickels are worth $10.80. How many coins have dates on them? So we're going to need to write two equations. One that describes just the number of buffalo nickels, and the other describes the amount of money from each of them. So we'll set these up and I'll let you work them out. But what we're going to need to do, first let's define, for the ones that without dates we'll describe as x, and the ones with dates are y. So if we have 32 total, the amount of without dates plus the amount with dates equals 32. And then the for the money part of this, I'm going to say, well, the ones without dates are worth 15 cents each. And the ones with dates are worth 75 cents each. And that's going to equal $10.80. A quick hint for you to start off, one way, especially when you're dealing with cents, I would actually turn all of this into, really into the amount of pennies by multiplying by 100. Then you're working with whole numbers. So instead of this equation, we would have 15x plus 75y is equal to 1,080. We could then transform one of these two equations, probably multiplying this top equation by maybe negative 15, so that I could add these up and my x's would eliminate. One other example, a museum sells 280 tickets in one day for a special exhibit. A regular ticket costs 20 bucks and a student ticket costs $14.50. How many student tickets did the museum sell if they made $4,918? Well, let's say a regular ticket is X dollars, or is X, and a student ticket is Y. So X plus Y equals those 280 tickets in a day. Well, each regular ticket is $20, and each student ticket is $14.50. And that's going to equal 4,918. In order to solve this one, I would actually multiply the first equation by a negative 20. That's what I would think to do. And when we do that, we end up getting a negative 20x minus 20y is equal to negative, let's see, 280 times 2. So we get a negative 5,600. So that when I add these up, my x's go away and I get a negative, let's see, 5.5y is equal to, well, let's see, what's the difference between these? 5,600 and 4,918. Let's do a little bit of this. Okay, so we get a negative 682, since that negative 5,600 is bigger. So that when we do this, I'm going to grab a calculator to do this a little bit quicker on this video, I would divide by negative 5.5, and so I would see that y, the student tickets, is equal to 124. Well, I can plug that back into one of my original equations, probably the top one, and say x plus 124 has to equal 280. Well, when we do that, we would say that the regular tickets, X is equal to 156. So what we're saying is that to get that amount of money out of the 280 tickets, we would have to sell 156 regular tickets and 124 student tickets. Well, I hope this helps with your homework and for studying.